Okay, so your lab this week, if we log in here, we'll show up. What's going on? It's gonna involve you doing some basic work using a computer software program called R. Okay, and so students have always asked, why did you pick R? And the main reason is that it's a great program and it's free. Okay, so there are other programs that are a little bit more user-friendly, okay? And depending on the field that you go into, people will have different preferences. So like in social sciences, SPSS is very popular. In other fields, SAS is more popular, okay? But SPSS, even like a student license, is like $150, and SAS, it's like $700 or $1,000 or something. And R, it's free, okay? And then you've got a lot of people contributing to it, and it's fantastic, okay? The downside to R is that it's hard to learn. There's a steep learning curve, okay? And if you have some background, like if you've taken a computer programming class, then things will be a little bit more familiar to you. Unless you've taken too many computer programming classes, and then you're like, certain things about R will feel a little bit funny. But if you've never taken a computer programming class, in the beginning there will be a lot of things that are just going to be frustrating, because it's like, why is the computer so stupid, right? Because little things make a huge difference. You put the quotation mark in the wrong spot, or you don't close off the quotation mark, the computer can't figure out what you're talking about, okay? You put a comma in the wrong spot, it breaks, okay? So what we want to do is you're going to just go to Google and you're going to type in R, and then and the first thing that pops up will be the R project for statistical computing, okay? And then you're going to click that, and then where it says download, you're going to click this thing called CRAN, okay? So CRAN is the network from which you can download R, okay? And it will probably say pick a mirror, okay? And then so there's all sorts of people around the world who are contributing to R. Probably your fastest downloads will come from the United States. We have a server at UCLA that serves R, but you could pick wherever else. But I go to the UCLA one, and then depending on your machine, you're going to download the Windows one or the Mac or whatever, okay? So download R, and then so for Windows you would download this file, and then you would install that, okay? Now if you and you can just finish and install R, and R will run, okay? I like to use RStudio. RStudio is just like it's a interface that sits on top of the base R. So R does all the program R that you'll download here will do all of the math computation and all of that stuff, okay? But it's very bare bones, okay? It looks kind of like you're typing into a console. But it works, okay? There's a program called RStudio, also available for free, that just makes the interface a little bit prettier, okay? Now, if you have a super old computer, and I mean like more than 6 years old, okay, I don't know what super old is, but if I'd say, RStudio might not like your computer, okay? Just to make it a little bit prettier and easier to deal with, it requires more computing resources. So you might have to use the console version of R. But I imagine most of your computers will be okay. Okay, so you'd go to RStudio, and they have a free version that is perfectly good for everybody. And then they also have an enterprise version, which is crazy expensive. And I guess if you're like working at Google and you need a commercial version, you can pay the $1,000 a year. But But the free one, the open source, that one's free. So you would download this one, okay? And then you download the file and install it, okay? So again, you have to first install R, and then you install RStudio on top, okay? If you try to go straight for RStudio, it's going to say, I can't find R, okay? Okay, so anyway, when you start up RStudio, it'll look something like this, okay? And it looks still kind of a little bit computer clunky, and has all of this stuff, okay? And this little thing right here means R is ready for input, okay? So it says it's ready to accept input, and when it's thinking, like if you give it something difficult to do, that'll disappear, and then only when it comes back will it be ready for input. Now, if you give it something that's really hard, a little stop sign will show up here, and you can say that's like your way to say, like, I changed my mind. Don't spend the next 10 hours trying to do this thing. Okay, so you can start off and you can just give it some simple things, and you can say things like, okay, what's 9 times 7, okay? And it says, okay, 9 times 7, that's 63, okay? It gives you a little bracket 1. This means this is a way, because R is designed for lots of data, sometimes your answer will have like 40 components, or 1,000 components to it, and so it indexes it, and it basically says the first part of your answer is 63, okay? R generally does not care about spaces, so we can say like 4 plus 7, oops, and then it says, okay, your answer there is 11, okay? You can give it like several things, and you can create something called a vector, okay? A vector, you use C and then parentheses, okay? And inside the parentheses you can put several things. You can do like 2, 4, 7, okay? And it just says, okay, there's 2, 4, and 7. And you can say, okay, well, I wanted you to take each of those and I want you to multiply each of them by 10, okay? And R says, okay, no problem, that's 20, 40, 70, all right? Okay? It's kind of neat, right? Okay, and then, all right, you can also ask R for simple things. You can say there's certain commands like the mean, okay, and you can say, well, okay, what's the mean? And I'm going to give you a vector, 2, 4, 7, okay, and it says, okay, the mean of those 3 numbers is 4.333, okay. If you want to just modify the last thing that you entered, you can just hit the up arrow on your keyboard. The up arrow will give you kind of trace through your history of what you've typed. So you can say, okay, well, I want to change that last number to 10, okay? And it says, oh, okay, well, here your mean is this, okay? You can also ask for the standard deviation. You change mean to standard deviation, and it'll spit all this stuff out, okay? Okay, so this is kind of neat. There's also shorthand, so like if you want like the numbers 1 through 10, you can do colon, and this is equivalent to saying 1, 2, 3, 4, 5, all the way up to 10. Okay. So 1 through 10 would spit that out, and so you can say like what's 1 through 10, and you can do, okay, well, add up, sum everything from 1 through 10, okay, and so it'll add up all of those numbers and do 55. And so, do you guys know like the story of Friedrich Gauss, and the teacher was like, add up the numbers 1 through 100? Oh, you don't know this story? Okay. All right, so yeah, sure. Okay, it's story time, guys. So there was Friedrich Gauss is like this brilliant. He's the guy who invented the normal distribution. It's actually called the Gaussian distribution. So his contributions to mathematics are wonderful. So anyway, when he was a kid, his school teacher said, all right, guys, I don't have a lesson, so add up the numbers 1 through 100, and when you guys are done, come give me this thing, okay? And so all the kids are like writing away, and Friedrich Gauss, he's like 9 or something. He's like, I don't want to do this. But if I think about this, 1 plus 100 adds up to 101. 2 plus 99 add up to 101. And all the way up down to 50 to 51 also adds up to 101. So all of these things add up to 101. And how many of these pairs are there? There's 50 of them. Okay, and then so 50 times 101, 5,050. And then and the teacher was like, "How'd you do this?" And he's like, "I'm brilliant." But anyway, what? He was like really young, and he came up with this in his head, and so anyway, but we can so the computer doesn't know this, but you can say, "Computer, do 1 through 100." And it will say, okay, I'm going to do it the old-fashioned way, but I'm really fast, so here's 50-50, okay? And then you can say, like, do 1 through 10,000. So the computer's just brute forcing this. It's just like 1 through 10,000, I'm going to add all of these up. And it says, okay, here's your answer. And there you have it. The computer is not smart like Friedrich Gauss, but it's very fast, okay? Anyway, there are certain things. It has a built-in binomial and built-in normal distribution, okay? So p-norm is very much like your normal table. So if you type in p-norm and you give it basically a z-score, it will tell you the area to the left. So what will p-norm 0 tell me? 0.5. So you say p-norm 0, it gives me 0.5. I say, okay, p-norm 1, if you look at your table, p-norm area to the left is 0.8413. R says, actually, it's 0.8413447. So it has a bunch of these, and you can give it like very precisely different things, and it will kind of give you this, it's got a very precise normal distribution thing in there, okay? It also has the it has the reverse here. Okay, so you could say, what is the z-score associated with the 90th percentile? Okay, so this would be q-norm. Okay, so you can say q-norm of 0.9, and this says 1.28, and this basically means if someone is in the 90th percentile, they would have a z-score of 1.28, or someone with a z-score of 1.28 would produce an area of 0.9. Okay, and you'll have some homework problems kind of going over this. Okay, and then but p-norm is even smarter than that. You can just say, like, okay, what percentage of women are shorter than 67 inches if the mean is 64 and the standard deviation is 3. Okay, or let me just change this to yeah, we'll do 67. Okay, so you can give it actual numbers. Okay, and when you say p-norm 67, mean 64, standard deviation 3, it'll say, oh, I know what you're talking about. That's actually p-norm of 1. The z-score is 1 there, and this is the area to the left. Okay, and there's also shorthand. You don't have to say mean 64, standard deviation 3. You can just kind of give it these numbers, and it will also understand what you're talking about. Anytime you have questions about a function, you can say question mark, I have a question, and you type in the thing, and it says p-norm, and then the help will appear over here. Okay, and the help, when you first read it, it's a little bit overwhelming. Okay, but the helpful parts are usage. Okay, and then tells you kind of like how to do these things. All of the arguments effectively are optional. Okay, almost all of these arguments are optional, especially if it has a kind of a default value. And then so the helpful part is the usage. Okay, the arguments give you kind of some details there, and then there are certain examples that you can kind of just copy and paste and see how they work if you're interested in this. Okay. The binomial table is also built in, or not binomial. The binomial calculator is built in, and the thing is for the binomial, you would use D binom rather than P. Okay, so all of these functions have a D, a P, a Q, and a R, okay? For the normal distributions, we use P to get the area to the left, and if you give it an area and you ask for the z-score, you would use Q, okay? For the binomial, we would most of the time just use D binom. So if I said D binom, what's the probability that Steph Curry makes 175 shots if the average is 1, if he's going to take 200 and the probability of him making a shot is 0.9, then we would type this in, and this would be the probability that he makes exactly 175 shots. Is that okay? And then I could say, okay, well, what's the probability that he makes 176 shots? And it gives me this, okay? And because we've got the computer, I can say, okay, well, actually give me all of these numbers for all of the numbers from 175 to 200, okay? And it says, okay, I've calculated 26 numbers for you. The first number is 4.44 times 10 to the negative 2, which is 0.044. Okay, so it's in scientific notation here. And then the next one is 0.05, so 5.683, okay? So it spits out all of these numbers for us, okay, 26 numbers. But this is actually not what we want. We actually want to know what's the probability he makes 175 or more. So what we're going to say is we're going to say, computer, add all of these together for me, okay? So we're going to say, do this, and then we're going to say, what? I'm going to put this into sum, okay? Okay, and then it says, oh, the answer there is 0.8995, okay, which came up pretty close to our normal approximation, which was, I think, 0.9032 or something, right? I think we can actually do, according to our normal approximation, we said your cutoff should be at 174.5, the mean is 180, and the standard deviation is the square root of 18, right? Oops. Okay, so yeah, our normal approximation says 0.9025, or I think our textbook said 0.9032 or something, and then here the true answer is 0.8995. So we see the normal approximation. It's pretty good. It's off only by a couple percentage points, or not even a full percentage points. It's off by like 0.003 of a thing. Okay. So we have all of this. Okay. The part of your and I'm going to run out of time here. Part of your lab is also to download a data set. Okay. And you're going to download the data set and you're going to load it into R. Okay, and I hope last time, let me just make sure this link still works. So yeah, so this is data from the World Health Organization, okay, and basically we're looking at a whole bunch of different countries. So for example, the Czech Republic, and we are looking at the I think this is the systolic blood pressure, okay? So the systolic blood pressure for all men in the Czech Republic is 131.1, okay? And then, in Botswana, the systolic blood pressure is 129.8, the average, okay? And it kind of has low and high values here. So you're going to want to load this into R. And so I'm going to you can load this in here, and so you can do read.csv, and I'm going to do URL of the location, and I'm going to store this as blood pressure, okay? And this is a command that should get our data loaded, and it does. Okay, and there's a few ways to do this, and I have some the instructions on the web page. Another way to do it is you can click this button that says Import Dataset, and it'll say from web URL. So there's a few ways. You can do from local file. You can download. You can copy that link, and it'll download a file to your computer, and you can do from local file and load it that way. Another way is you can do from web URL, and you just kind of paste in that URL, and it'll try to try to figure it out, and it says, and it pulls up this kind of little wizard box, and it says, okay, well, what do you want to call your data set? So, you know, you can give it a name like blood. I called it mine BP or something, okay? And it just says like, okay, just make sure it kind of looks like the way you want it looking. And I say, okay, yeah, that looks good, okay? And there you go. The data is now loaded into R, okay? And so we can ask R, and I apologize for going over, is that, you know, you can call out certain columns using the $sign. So I can say, okay, let's look at blood, $, and we're going to look at country, okay? $, country, and so basically this just says here's the country here, and so here you can see all of these things, and you can see the first item in country is Czech Republic, the second one is Botswana, and then we have Dominica, St. Vincent, and the Grenadines, and things like that, okay? And so we can subset all of this stuff. We can say like, okay, what was the 15th item in country? And so I would use a square bracket to say blood, $, country, to say look at the column country, and then square bracket 15 says give me the 15th element in that thing. And it says, okay, the answer there is Bolivia, plurinational state of. I didn't realize that was the official name of Bolivia, and so that we have that, okay? Now we want to do work on the column numeric, okay, which is the numeric value of the blood pressure. So I'm going to just say, okay, instead of $, country, I'm going to say $, numeric. And it says, okay, for that, the value is 119.8, okay? And I can now just kind of say like, or all of these values, and it gives me all of these things. I can also ask, hey, what is the mean blood pressure? What is the mean of all of these numbers here? Okay. Now when I do this, it's going to say I can't tell you the answer. It's going to say NA. And the reason why is because a few of these countries actually are missing values here. Okay. And so because we're missing some values, it says, well, I don't know what those things are, so I would be lying to you if I told you I knew what the average is, right? Because if I said, you know, I've got some family has 3 kids, the 2 oldest kids, or 2 of the kids are aged 10 and aged 9, but I have no idea how old the 3rd kid is. And I said, what's the average age of the kids? You can't just say the average age of the kids is 9.5 because you don't know how old that 3rd kid is, okay? And basically that's what R is saying. R is saying is like, because I'm missing some information, I can't give you an answer. So you have to tell R, well, it's okay that you're missing this information, okay? And you say NA.RM means remove the NAs or ignore the NAs, and you say, okay, NA.RM is true, ignore those things. And then it says, okay, well, if I'm going to ignore the fact that I'm missing some data, I can tell you that the mean is this, okay? You've got a few things in here. I've tried to give you some guidance online on how to do certain things. Some of it, you're going to have to go on Google and say, like, how do I do this? And then, of course, if you get stuck, send me an email. I recommend that you try to get started on it over the weekend rather than waiting till, like, Wednesday of next week. With the lab. So try it out. Don't hesitate to email me if you can kind of, if you're getting errors and stuff, you know, copy and paste the text of the error into your messages, and I'll try to respond. All right, we'll see you guys next week. Good luck.